So the topic of Lab 7 is functions, and this is how functions look like. You have this define command and then the name of the function. Let me max this out a bit. So you are defining the function called myAdd, and you provide two arguments, and this could be any number of arguments, any variable name. And here we are returning the sum of x and y. So if you define any two variables and you call the function with the name provided here, and you provide two arguments, so the number of arguments has to match the function definition. So both the function name and the function arguments have to match. So this is the function name, these are the two arguments, and whatever is returned here will get assigned to this variable. So if you do this, it's not going to work, right? Because it expects two arguments. So this will be a syntax error on missing position argument, which is y. So y is missing. You could put values directly, but this is always a bad idea. This will work because there are two arguments. So really this can be any two variable names. And it's important to assign whatever is returned by the function to a variable. So that's pretty straightforward. Very important to remember those two things, right? Just like with if statements and with for loops, you have a colon at the end of the line, and then you hit enter and you should have a tab. So colon and tab, very important in your function definitions. And your function definition needs to come before you actually use it, right? So if you had put this before this, then it doesn't work because myAdd doesn't exist as at that point. We can return multiple variables or multiple values by separating it with commas. So we can return the square of any given input value. We can return the cube of any input value, and it's just comma separated, so it's going to come out as a tuple. So whenever you call this power function, you need to provide how many arguments on the left side? You need to provide two variables on the left side. So two variables on the left side of the equal sign, so that the first goes in square and the second goes into cube, and then only one argument to the function, because that's how this function is defined. And so that's how that will work. This will return 3 squared and 3 cubed, which are these and that respectively. All right, good. We can have we can have default values. So this would have worked, right? But if we set it to a value, it means by default country will be USA. So if you don't provide any other, if you call the function and you don't provide an argument, then country will be USA, and it will just print out I am from USA. Notice there is no return function here, which is why we don't have a variable equal to this, right? Because you're not returning anything. It just does some work, and here it just prints. But if you specify Canada, then country becomes set to Canada, and you print out I am from Canada. And you can do the same with India, and you obtain these results here. Another thing you can do is you can provide a list or a collection, a tuple, dictionary, whatever, as an argument to your function. And then if it's a list or a collection, you can actually iterate through the item. So here we provide a list of fruits, which is essentially a list of strings. And then within the function definition, we have a for loop, and we are basically printing out each item one at a time. And there is no return statement, so you just call the function without assigning the results from the function to any variable. And so it prints out each of the item one at a time. You can have any arbitrary number of arguments by using the star keyword. So if you use star and any variable name, then if you provide 4 variable names, it goes in as a list containing 4 items. If you provide 3 variable names, then kids list will contain 3 items. It will contain 2 if you do this. And then here we're just printing out the first item. So first time to is Peter, second time it's, and we call it this time it's James, when we call it here it's LeBron. If you call it this way, then it will print out 3. So it really can be any list of items, whether it's a string, integer, floating point, the code all works the same. So like I explained in class, I can ask you to write one generic function that can work either for exponential or hyperbolic, knowing that the exponential requires 2 arguments, which are what? Ky and di, whereas hyperbolic requires 3 arguments, which are ky, di, and b. And so you can provide this list, which will work for ky and di for exponential, and ky, di, and b for hyperbolic. And based on the length of these, you can choose between these or that. And so if number of arguments is equal to 2, then it's exponential, right? Otherwise it's hyperbolic. So this is how you could use this star variable name to work within the context of our decline curve analysis. Then in class I covered recursion, and this is as simple as having a function call itself. So if a function calls itself, it's called a recursion. So this is Fibo function, and within Fibo function we call Fibo. So this is a recursive call to Fibo. So this is recursion, and we're using it within the context of Fibonacci series, which is a series that starts from 0 and 1. So 0 and 1 are the first 2 items in the Fibonacci sequence, and then all subsequent indices are the sum of the 2 previous terms. So the third term will be 0 plus 1, which is 1. The fourth term will be 1 plus 1, which is 2. The fifth term will be 1 plus 2, which is 3, and so on. Good. So here we'll take in any number of terms. You're familiar with this already, right? And then we have a loop that goes from the first to one short of the number of terms, and systematically we continue to print the Fibonacci, the term in the Fibonacci series that corresponds to I. So if we run it and provide I equals 2, I will go from 0 to 1, right? It doesn't get to 2. So if I is 0, you're printing Fibonacci of 0, and so we come here, is 0 less than or equal to 1? Yes, so it returns 0, and you get this. And then it goes to the second term, which is 1. So Fibo of 1, it comes in here, n is equal to 1, so it returns 1. That's how we got 0 and 1. What if it's 3? We'll start out with 0, 1, and then stop at 2, because you have asked for 3 terms. So 0 and 1 gets you 0 and 1 as discussed before, and then 2, which is the third term, and 2 is greater than 1. So this isn't true. So it comes in here, and you're looking for Fibo of 2 minus 1 plus Fibo of 2 minus 2, which is basically Fibo of 1 plus Fibo of 0. And then it will call Fibo and goes back here with 1, it returns 1, with 0, it returns 0. So you get 1 plus 0, and that is 1. And that's why this term is 1. And we can repeat that for 4, and this is the last time I'm running this, and it's going to go from 0 to 3, right? So Fibo of 0, Fibo of 1, Fibo of 2 gets you these, and the last term, which is Fibo of 3, we get in here. 3 is not equal to, it's not less than or equal to this, so it comes in here. I'm looking at fib of 2 plus fib of 1 because n is 3. Fib of 2, then it calls fib and comes in here, and fib of 2 gets you back here again because it's not less than or equal to 1. And this time around, you're looking at fib of 1 and fib of 0, which is 1, right? And then the other term, which was fib of 3 minus 2, is fib of 1, and that is 1. And you add those three terms together and you get 1 plus 1. And that is, it's basically 1 plus 1 plus 0, right? And you get 2. So this is how the recursive function works. And like I explained in class, all recursive codes could be implemented using loops. And when you use loop, it's faster because you don't have to call the same function over and over and over again, which uses up a lot of memory and is also slow. So this is how you would implement the Fibonacci series using a loop. So there will be no recursive call to Fibonacci within Fibonacci. Start out A equals 0, B equals 1, and for I in range n, we basically create a temporary variable that shifts A and B backward 1, meaning make temporary equal to A, make A equal to B, and then update B. So I hope that's clear. We make the second term equal the first term, and then we update B. So that's why temp has to be set to A. Basically, A is assigned to temp, B gets assigned to A, and then we update A as the sum of the previous two terms. And then we return A. Very important. What we return is A and not B. So these all look like before. So let's run it and think through it starting from 2. When we go in with 2, I goes from 0 to 1, right? We don't get to 2, so it's 0 and 1. So we need to call Fibonacci with 0 and Fibonacci with 1. So when we call Fibonacci with 0, we come in here. Range of 0 is an empty list, and I show that here. If you go in there and do range of 0, what you get is an empty list. Why is that the case? I mean, think about it. If you ask for range of 1, you wouldn't get to 1, so you stop at 0, so it's only one item and it's 0. But when you go to 0, it doesn't get to 0, so there's really nothing in there. Okay, so first time through, when you go in with Fibonacci and I is 0, well, this loop doesn't execute because this range of 0 does not exist. It's empty, so it doesn't even execute this, and you just return A, and that tells you that first term is 0, which is why we got 0 here. And then when we go with Fibonacci 1, then we come in here and it will be executed one time because I will be 0 only the first time through. And then temporary becomes A, which is 0. A, which used to be 0, becomes 1, which is what B is, right? And then B gets updated as the sum of A and B, which is temp, right? What A was before, 0 plus 1, and that is still 1. So B is 1, but what do we return? A. So we return what? A has been updated to be B, which is 1. So what we return is 1. That's why this term is 1. And then if you look at it and you run it for 3, so here we're going to do 0, 1, and 2, right? You don't get to 3. So 0, 1, and 2. Those are the 3 terms. 0 and 1 we already discussed. And then let's focus on the third term here where I is actually 2. So Fibonacci of 2, we come in here. I range of 2 means you have 0 and 1. So you run this in twice. First time temp is 0, right, which is A. A becomes 1 because B is 1, and then B becomes A, which is 0 plus temp, 0 plus 1. So B becomes 1 the first time through. But what do we return? A. But we are not yet returning, right? Because we're still inside this loop. We're going to execute this loop 2 times because we went in with I as 2. And then the second time through. So before we go to the second time through, let's review again. Right now, after running this the first time, A becomes 1 and B becomes the sum of 1 and 0, which is still 1. So both A and B are 1. after the first time through this loop. Then the second time through, you set them to be a, which is 1, a to be b, which is 1, right? And then b gets updated as 1 plus 1, right? The 1 in that was in a before plus the 1 in b, and b becomes 2 the second time through. But what do we return? A, so we return 1. That's why this is still 1. And when you run this and we ask for 4, this is the last time I'm running this, we already know how we got 0, 1, 1. For 4, number of times we go from 0 to 3, right? It never gets to 4. So you're running this thing you're running this thing 4 times with 0, 1, 2, and 3. So we already know how we got 0, 1, and 2, which is these 3 terms. And now let's look at when we go with I equals 3. So we go with I equals 3, we come in here, we're going to run this in 3 times, for 0, for 1, and for 2. So 3 times, very important. So first time through, temp is set to 0, A is set to 1, right? We're just looking at these 2 terms. And then B is 0 plus 1. So A becomes 1, B is still 1 because temp is 0. So A and B are 1 after first time through. We're going to run 3 times. So second time through, temp is 1 because A is 1. A is set to B, which is also 1, right? And then B gets updated to 1, which is what A was at the end of the first time step, plus B, which was still 1. So 1 plus 1 is 2. So B is now 2 at the end of the second iteration. So A is 1, B is 2. And then we go the third time through. Temp is set to A, which is 1. B used to be 2. It's now, so A becomes 2, right? A becomes 2. A temp is 1. And then B gets updated as 1 plus 2, right? And that's 3. But what do we return? A, which is 2. And that's how we get to right here. So this is another way to implement the Fibonacci series using loops without recursion. And that takes us to the realm of dynamic programming. So you will see dynamic programming questions a lot on job interviews for the tech industry. They ask you to implement an algorithm. You will figure out the easiest way to implement the algorithm is using recursion, like so, and then they'll ask you to implement it much faster, and that requires you to implement it using a loop because this saves more memory, and they use the word memoization. So you minimize memory. I should say you minimize the use of memory using this approach. And that's pretty much it. So we'll continue from here in the next video.